Hi students, today we are going to discuss about internal resistance of a cell. We are going to discuss about internal resistance of a cell. Okay, so internal resistance is a resistance offered by the electrolyte. It is the resistance offered by the electrolyte when a current is passed through it. When a current is passed through it. Okay. So when no current is passed through it, no internal resistance come to play. So internal resistance means the resistance offered by an electrolyte when a current is passed through it. Okay, that is called internal resistance of a cell. And this internal resistance depend on many factors. It depend on many factors. One of the factor is the nature of electrolyte. Is depend on the nature of electrolyte, and second one is a distance or separation between the electrodes, and another one is the area of the electrode, and another factor affecting it is temperature. Okay, so these are the factors affecting the internal resistance of a cell. Okay, suppose the switch is open in a circuit, the key is open. Okay, when a key is open, no current is passed through it, so the internal resistance of that cell is 0. When circuit is closed, that time a current is passed through between the electrodes through electrolyte. So a resistance is offered. That resistance is called internal resistance. Okay. So now we already discussed about the internal resistance. Now we are going to discuss how we can determine the internal resistance of a given cell. Given cell. So we know that internal resistance depend on many factors. Okay, one is the nature of electrolyte, then separation between the electrode, the area of the electrode, temperature, and many factors are there. So these are the many some factors related to the internal resistance of a cell. Okay, so we will derive an expression for internal resistance. So we consider a cell. Here I consider a cell. This is cell, and this is a positive terminal and negative terminal. Okay, and it's connected to an external resistance. Capital R through a key. Here K is a key, and this is positive terminal, and this negative terminal. E is the EMF of the cell. It's connected to an external resistance R. Okay, so here key is open. Now I connected a voltmeter between the positive and negative terminal. A connector here, circuit is open, and I connected a voltmeter between two electrodes. That time the voltmeter read a value that is called EMF of the cell. So EMF of the cell means it is a potential difference between terminal of a battery or a cell when no current is drawn. That is called EMF. So here we consider circuit, and a battery it having voltage E and is connected to a key through a resistor. And I connected a voltmeter between the positive and negative terminal of a cell. That time voltmeter read a value. That value is called EMF of the cell. So EMF mean it is the potential difference between the terminal of a cell when no current is drawn from the cell. And after that, I on this key. The key. That time the voltmeter read a less value than before. Okay, then second we put the key here, and that time the voltmeter read a value which is less than what we see before. Okay, that is called terminal potential. That is called terminal potential. That is called terminal potential. So terminal potential is the potential difference between the electrode when a current is drawn. A current is drawn. That is called terminal potential. So EMF and terminal potential. The terminal potential is less than the EMF when a current is drawn through the circuit. Okay, that means in a closed circuit, okay, suppose the battery is discharging. Okay, the terminal potential is less than the EMF of the cell. Here in this case, the battery is discharging. So here the terminal potential is less than the EMF of a cell. How we can determine the terminal potential, that we are going to discuss now. Okay, so this is a circuit, a current is passed through it, I is a current passed through the circuit. Okay, so this is a series connection, so we can write the total EMF. Total EMF is given by E is equal to, is the total EMF drawn from the cell, that is equal to IR plus. So I is a current through the resistor, so across this there will be potential drop, that is equal to IR plus. And when a current is drawn, an internal resistance comes to play. Okay, the cell is offer a resistance, so when a current is passed through it, so due to the internal resistance, some potential drop will be there, that is given by I into R. So we get E is equal to IR plus I into R. Okay, here this IR is the potential drop across resistance, that is considered as terminal potential. So we can write E is equal to, this is considered as a terminal potential, which is written as V. So we get V is equal to E is equal to V plus IR. So we can write V is equal to E minus IR. Here V is the terminal potential, E is the EMF of the cell, I is the current drawn, and R is the internal resistance of a cell. Okay, clear? So when switch is on, a current is passed through it. So we found the total potential in this circuit, that is given by E is equal to IR plus I into small letter r. Here small letter r is the internal resistance. So here we consider a current is passing, there will be potential drop, that potential drop is equal to the applied voltage now, that is given by the terminal potential. So E is equal to IR plus IR, so E is equal to V plus IR. So from this we can write V is equal to E minus IR. So this is the equation for finding terminal potential when the battery is discharging. Suppose the battery is charging, then the terminal potential can be represented by V is equal to E plus IR. V is equal to E plus IR. Okay, in this circuit, IR, in this equation, IR is called the lost voltage. It's called the lost voltage due to the internal resistance. Okay, now we are going to discuss how we can determine the internal resistance of a cell. So we got the equation for find the terminal potential, V is equal to E minus IR. Okay, we need to find out the internal resistance, equation for internal resistance. So we know that V is equal to E minus IR. So from this equation we are going to write, that is, this equation can be again written as like this, V is equal to E minus IR. So from this equation we can write IR is equal to E minus V. So we can write R is equal to E minus V by I. R is equal to E minus V by I. So when we are considering this equation, because this is a series combination, we can write the current in the circuit is given by I is equal to E divided by R plus R. E divided by R plus R. Okay, current in the circuit is given by is equal to E divided by R plus R. Okay, clear? From this equation we can write R is equal to E minus V by I. Okay, so this is the equation of finding the internal resistance of a cell. So R is equal to E minus V by I. Okay, but here I is the current that is given by I is equal to E divided by R plus R, or otherwise we can write according to, we know that V is equal to IR, because this is a voltage across this resistor. V is equal to IR, that is a voltage across the resistor. So we can write I is equal to, therefore I is equal to V by R. I is equal to V by R. Okay, here we consider a current is passed through, there will be potential drop. The potential drop is given by V is equal to IR, so I is equal to V by R. So we substitute the value of I, then we get R is equal to E minus V divided by, instead of I we are writing V by R. So R is equal to E minus V by V into R. So we can write R is equal to E by V minus 1 into R. So this is the equation for finding the internal resistance of a cell. Here R is internal resistance, E is the EMF of the cell, and V is the terminal potential, and R is the external resistance. So when external resistance is varied, the internal resistance also changes. So this is the equation for finding internal resistance. So we know that what is internal resistance? Internal resistance is the resistance offered by the cell when a current is drawn. Okay, so and we also study about what is EMF and what is terminal potential. EMF means when circuit is open. When circuit is open, that means there is no current drawn in the circuit. Okay, so if you have measured the terminal potential between the 2 points, that means potential, not terminal potential, potential between two electrodes, okay, we get a value that is called the EMF of a cell. So EMF means is the potential difference between two electrodes when no current is drawn. Okay, terminal potential means, okay, when circuit is closed, a current is passed through it, and that time the voltmeter read, okay, but if you are measuring the potential difference between the two electrodes, that value will be less than what we got before. That means is the potential difference between two electrodes, okay, when a current is drawn. That is called terminal potential. Okay, so this is about internal resistance.